Okay.
Yeah. So yeah.
Well, I'll go ahead and start. You want me to go ahead and just
Yeah.
say my spiel?
Yeah.
Okay. Hi, guys. Miss Jordan here. I just wanted to crash your Zoom so you could see that I'm still here. If you need me, you can email me. If you want to write down my email, it's lmjordan@kermitisd.org. If you want to talk to me on the phone, use that email and send me the phone number that you want me to call you on or text you on if you'd rather do that. You can also call the school and the school can relay the message to me that you want me to get a hold of you. But I miss you all and I know you're doing such a good job. I'm so proud of you all showing up for Mr. Guieta's Zoom. You guys are awesome, doing good. We're proud of you. And I'm going to go now, but I just want you to know that I'm here. However you want to get a hold of me, you just let me know. Okay? Bye.
All right. And I think I put your, is that email correct? The one at the very top of the whiteboard there?
I can't see it. It's too small. It's lmjordan@kermitisd.org.
Okay, awesome. Yeah, I have it up so that way, just in case if they want to write it down, they can do that.
Thanks, guys. You guys have a good day now.
All right. Thanks, Mrs. Jordan.
Bye.
All right. So, all right, guys. So I'm gonna go ahead and get started. I know I got an email earlier today from your guys' coach. I think it's Miss Coach Brown. And so he was mentioning that I guess he gave you guys an assignment of trying to do something like staying active. He was mentioning, walking, jogging each day. I know I'm for one walking and jogging every single day. So right now I'm doing like about 3-4 miles every day just to kind of do something, get out of the house. It's good to get some fresh air and some sunlight. So, I would recommend if you guys have the chance to do that, get outside, do something. So that way, at least you're not bored at home all day and playing video games or watching videos or whatever it is. So for, and that's for Mr. Brown, your guys' coach. That's what he had sent out earlier. So just wanted to remind you guys of that. So right now we're going to cover assignment 15. So assignment 15, it's basically covering the same stuff that we've been covering this entire time. We're pretty much getting to the end of this unit. You guys already, a lot of you took the test. For those of you that haven't taken the test yet, it is due tonight by midnight. So if you have time right after this, you can take it. It probably takes only about 20 to 30 minutes at the most to finish the test. So if you guys can, try to do that. And normally, the students that wait to the very end, because I have seen students that you do wait till the very end, it does notify me like what time you actually finish it and submit it. Normally if you start at the very, very end, like if you started at 11:30 p.m. or if you wait till 11:45 and you're, starting it at that point, it's going to cut you off. And all the questions that you didn't finish, it'll just show them as wrong, that you got them wrong. Or even worse, it'll show me that you didn't even do it at all. And it'll kind of show me that you got a 0 because you didn't turn it in at all. So if you can, the sooner the better. So on assignment 15, we're just going to cover some things that we've been covering already quite a bit. So I'm going to cover some on assignment 15. We're covering again, same thing that we've been covering for, I guess, like the past month. I'm going to cover what's a whole number, what's an integer, what's a rational number, what is like how to subtract integers, how to add integers, how to convert a mixed fraction to a regular fraction, how to add fractions, divide fractions, multiply fractions, That's all stuff that we've been covering for the past month, more or less. I see that a lot of you guys are getting it and you're doing really well on the quizzes and on the assignments. I still see a few people that are struggling. Like the test, the people that have taken the test, I saw a lot of hundreds. I saw some 95s, some 90s, a lot of people that are passing. But then I still saw that there are some people that are still failing them. So same thing, I am going to record this afterwards. If you want, rewatch it after this, and you can fast forward through the parts that you feel like I'm talking too much, like right now. You can fast forward to the good parts and actually, you know, just recap the how to do the solving of, you know, dividing or multiplying, and you can just listen to it over and over. And then right before you take the test, then, you know, it'll help you out if you rewatch it. So I'm going to go ahead and get started here. And the first thing I'm going to cover is what is a whole number. So I think that most of you guys have already understood this, but whole number, and then I'm going to do, after that, I'm going to give some examples of a integer, and then I'm going to give some examples of a rational number. So whole number. So we'll start with that one first. So for whole number, it's basically any number that doesn't have a decimal after it. It's not a fraction. It's just a regular number. So some examples of that would be like 4. Even some numbers, like let's say we have something like 3.0. Even though there is a decimal there, 3.0 is the same thing as saying just a regular 3. It's like saying it's just a 3, because that 0.0 doesn't really matter. It's really like you're just saying 3. So even the ones that say 3.0, that's still a whole number. Anything like even large numbers, like if you have something like 1,247, something like that, that's still a whole number, even though it's a large number. If you have something like 372, that's still a whole number. So basically any just normal numbers, no decimals, no crazy fractions, nothing like that, just regular whole numbers, no negatives in there. So that's whole numbers. So now let me do integers. So integers are basically whole numbers, but just with a negative sign in front of it. So integer would be like -4, -37, -125. And then same thing like the whole numbers, even for ones that say like -3.0, that's still a whole number. Even if it's 3.000, that's still a whole number. The only time that it turns into a rational number is if you have something like -3.0001, then that would be considered a rational number, because now you're adding an actual number in here in the decimals. But if it's just something like 3.00, then that would still be an integer. So let me erase that. And I'm going to try to do everything in this corner over here of the whiteboard, because later on, then I can crop out the video side of it. So, so rational number. Rational number. So for rational numbers, it's going to be all of the weird numbers. I mean, everything that's just not a normal number. So it's going to be things like 4.23, 4.07, all the fractions like 3 over 12 or 27 over 4, anything like that. So any of those are going to be rational numbers. So anything that has fractions in it, decimals, even if it's a negative number, it's still considered. So if I say that it's negative 4.07, still a rational number. It's not considered an integer because it's an actual decimal. So it's not a whole number that's negative. It actually has a decimal after that. So that'll be rational numbers. So that's that. So by now, I think the majority of you have already gotten a good grasp of those, of whole numbers, integers, and rationals. So now let's go into the more complicated stuff. So so far, I have been seeing a lot of improvement on the negative numbers when you add them with positive numbers, or positive numbers when you're subtracting a very large negative number, something like that. So let me do an example of that. So let me write down here, subtracting and adding integers. So let's do something like negative 19 minus 3, something like that. So with negative 19 minus 3, what you have to do first is you have to figure out what sign each one is first. So like negative 19 is a negative. This 3 right here has a minus in front of it, so then that's also considered a negative number. So this will be negative 19 and negative 3. So both of these are going to basically combine together. And so all you're doing is you're adding these 3 negative onto these negative 19. So the number is actually going to go up. So it's going to be negative 19, 20, 21, 22. So that'll be a negative 22 right there, because they're both the same sign. That's why. Now, if you do something like negative 19 minus negative 2, now this is very different, because now there's 2 minuses right in front of each other. So this number right here, it's a negative number. But this number right here has 2 negatives. So there's a minus and a negative together. So when that happens, these 2 combine and they form a positive. So now the equation is 19, a negative 19, plus 2. So this is a positive 2 now. So now 2 of these numbers are going to cancel out 2 of these numbers. So this is actually going to go down. So this is going to go down to negative 17 now. And if you have to, like I said, I mean, if you have to draw those circles out, you can draw the circles out. But bottom line is you have to know that these are 2 different signs. So that means that the 2 of these numbers are going to cancel out 2 of these numbers. So this is going to actually go down. So it's going to go down to negative 17. Now, if you have something like 18 minus 20, this is something else that I've been seeing that a lot of people are having trouble with. So this number right here in the front is a positive because there's no negative in front of it. And then this number right here is negative because there's a minus in front of it. So 18 of these positive numbers are going to cancel out 18 of these negative numbers. So then you're going to be left with a negative 2 at the end of that. So that'll be that right there. So at the end of all of that, then you're going to be left with that negative 2. So that's adding and subtracting integers. So for the most part, I have been seeing a lot of you guys are understanding this, but I'm still seeing that a few people are having some trouble with understanding the when you're subtracting a bigger number or these two, when there's two minuses in front of each other, then it's going to turn into a positive. So those are just little rules that you have to remember. So let me erase all of this stuff. All right, so now let's go into mixed fractions to fractions. So mixed fractions to fractions is going to be something like this. So let's say that there's a 3 and 1/4. So 3 and 1/4. So when you have something like that, 3 and 1/4, this is a mixed fraction. A lot of times when you're adding or subtracting or multiplying or dividing fractions, you have to turn this into a regular fraction first before doing the equation. So the way to convert this into a regular fraction is you multiply this big number times a small number down here. So 3 times 4, and then you add the number that's on top. So 3 times 4 is 12, plus 1 is 13. And that 13 is going to be on top. And then this 4 number is just going to stay there. So it's going to stay on the bottom. And it's going to go over here, and that's going to be here. So 3 times 4 is 12, plus 1 is 13. That's on the top. And then the bottom number that was here stays on the bottom. And now this is a regular fraction. So sometimes it can be a very large number. So if you have something like 5 and let's say it's 9/12, something like that. So that's actually going to be a very large number, even though it doesn't look like a big number here. Once you actually calculate it out, then it will be a large number. So now you're doing 5 times 12 plus 9. So if you actually work out 5 times 12, that's going to be 60. And then you add the 9, and then that'll be 69. Over 12. And then if you can simplify it, then you simplify it. So both of these numbers can actually be divided by 3. And then so top number is going to be 23. And then 12 divided by 3 is 4. So that would be your actual answer. So all of these numbers, once you actually get the first fraction, you have to ask yourself, okay, well, after that, can I simplify these two? So you have to figure out like 13/4 up here, that one can't be simplified any further because nothing will go into both of these. So that's changing a mixed fraction into a regular fraction. So now let me go to the next part, which is going to be, let me see. So adding fractions. So adding fractions, I still am seeing a lot of difficulty. So when you're adding fractions, the first thing that you need to do is, let me put that right here. Adding or subtracting fractions. So the first thing that you have to do is, let's say it's something like 4/9 plus 3/9. So if you have something like 4/9 plus 3/9, this is easy because both of the bottom numbers are the same. So when both of the bottom numbers are the same, you just leave it the same. So it's 9, it'll stay 9. And then all you're doing is you're worrying about the top one. Whenever you're adding or subtracting, it's the same. So If the bottom number is the same, you're golden. It's going to be super easy because then you just leave the 9 down here, and then all you're doing is 4 plus 3. Super easy stuff. 7. So now your new number is 7 over 9. And that's easy. When they're not the same, so let's say it's the same thing, 4 over 9. 4 over 9 plus 1 over 3. Now this is different because what you have to do first is the bottom numbers aren't the same, so you have to make them the same. So the only way to make 1 over 3 the same as this over here is you would have to multiply. So you would multiply that 1 over 3 times 3, because that 3 times 3 would equal 9. So now your new fraction would be 3 times 3 is going to be 9 down here, and then 1 times 3 is going to be 3 over 9. So now you can erase this 1 over 3, and now the new answer, it actually ends up being the same as the one up here at the top. So 4 over 9 plus 3 over 9, and now that the bottom number is the same, then you leave the 9 the same, and then all you're doing is you're adding across. So 4 plus 3 is 7, so 7 over 9. And that's it. So that's for adding. For subtracting, basically the same exact thing. So now let's see some subtracting ones. If the bottom number is the same, then you're golden. So let's say it's something like 6 over 7 minus 2 over 7. Bottom numbers are the same, so that's easy. You just leave the bottom number the same over here, and all you're doing is 6 minus 2, which is 4. That's it. So now let's do an example where the bottom number isn't the same. So let's say that 6 over 7 minus 10 over 14. So now the bottom numbers aren't the same, so what you have to do is you have to make them the same. So the only one that you can really do is you can either divide this one by 2 or you can multiply this one times 2. I think multiplying by 2 is easier, so if you multiply this fraction by 2, it'll be 7 times 2 is 14. And then the top number is 6 times 2, which is 12. So now you can erase this right there. So let me move that up. So let's say it's 12 over 14 minus 10 over 14. So now this is much easier because now you're doing the same denominators. So 14 is going to stay down here. And now all you're doing, the actual problem is just 12 minus 10. So 12 minus 10 is just 2. And then at this point, this is the answer, but now you can simplify. So we can divide both the top and the bottom by 2. So when you divide both by 2, it's going to be 14 divided by 2 is 7. 2 divided by 2 is 1. So 1 over 7. And that's your actual answer. So whenever you're adding or subtracting fractions, you make sure that the bottom fraction or the bottom number, the denominator, is the same. If it's not the same when you're adding or subtracting fractions, then you have to make it the same. And usually you can do that by multiplying by 2 or 3, and you should be fine. There's not going to be really anything more difficult than that. Okay, so now let me see what's next. So next one, we're getting towards the end here. is just regular multiplying and dividing fractions. So now let's do that. So multiplying and dividing fractions. So now it doesn't matter what the bottom number is. So denominators don't have to be the same when you're multiplying or dividing fractions because you're really just multiplying across. And I'll show you some examples of that right now. So let's say it's 3 over 4 times 6 over 7, something like that. So when you're multiplying two fractions together, bottom numbers doesn't matter whether they're the same or not. So the denominator does not have to be the same. You're multiplying across. So all you're doing is 3 times 6 and 4 times 7. So 3 times 6 is 18. And 4 times 7, 28. So normally that would be your answer right there. But in this case, you can actually simplify that. So you can divide both the top and bottom by 2 because they're both even numbers. So you divide both top and bottom by 2 to simplify it. And so now 18 divided by 2 would be 9. And then 28 divided by 2 is going to be 14. And then at that point, you have to see, okay, well, can I simplify it even more? Can I divide both by 3? 14 can't be divided by 3, so that's your answer. So 9 over 14. So that's when you're multiplying. When you're dividing, it's basically the same exact thing. When you're dividing fractions, it will end up multiplying anyway. So let's say the same example. So let's say, let's do something different. So let's do like 2 over 3 divided by 4 over 5. Something like that. So when you're dividing two fractions, what you're really doing is you're getting the reciprocal and then you're multiplying them. So the new question is actually going to be 2 over 3 times 5 over 4. So you see what we did there? So all we did is we flipped this second fraction around and we changed the divide into multiply. So now you're doing 2 over 3 times 5 over 4. And now, just like how we did up here in this example, you're just multiplying across. That's it. So multiply both across. So 2 times 5 is 10. And 3 times 4 is 12. And then both numbers are even, so you can divide by 2 to simplify it. So divide that by 2. And then now your new answer is going to be 5 over 6. And that's it. You're done. So let me see. I think I got one more example here. Yeah. So let me do one more example and then we'll be done after this one. So one more example that I'm going to do is when you're adding mixed fractions and regular fractions. So let's do that. So a little while ago, we just covered how to change a mixed fraction into a regular fraction. So in this case, it's the same thing. So let's say it's 2, 1 over 3 plus 1, 1 over 2. Something like that. So in order to do this problem, you have to change both of them to regular fractions first. So the first step is that let's do this 2 times 3 plus 1. So 2 times 3 is 6 plus 1 is 7. So it's going to be 7 on the top and 3 on the bottom. You leave that 3. plus 1 times 2 plus 1. So 1 times 2 is 2, plus 1 is 3, so 3 over 2. And then now you can actually solve this problem. But what you have to do is neither one of these, the bottom number is not the same. So what you're going to have to do is multiply it to get the common denominator. So this one can be multiplied by 2. And this one can be multiplied by 3, and then the denominator will be 6. So 3 times 2 is 6. 7 times 2 is 14. Plus, over here on this side, 2 times 3 is 6, and 3 times 3 is 9. Now the denominators are the same, so now all you're doing is you leave the 6 on the bottom, and then now you're just adding 14 plus 9. And so 14 plus 9, 23. That's it. So, and this one, if you can simplify it, then you would simplify it, but that's it. So if you guys have any questions about the test, about any of these examples, just send me a private message and I'll answer that. I'm going to upload the quizzes link for assignment 15 right now in about 5 minutes. I'll upload that. And also just remember that if you haven't done the test, that you have to finish it by tonight at midnight, which means that if you wait till the last minute, you have to at least give yourself about 30 to 45 minutes to finish that test. So I would do it right now if you can, if you haven't done it yet. So that's it. All right. If you guys have any questions, just let me know. All right. Bye, guys.